Kids, what's up? Professor Thomas here. Yikes, science hack. If you're here in this video, you are getting bonked by yikes problems. So let's go in here and we're going to take a look at science in general. We'll take a look at the yikes and we'll do a quick review of pretty much everything. All right, so what is yikes? All right, yikes means you did exactly what I taught you and what they're looking for you to do. However, we're still stalling out and can't answer the question. Most of the science that we're going to be dealing with is just really finding the correct area in the passage. And how do we usually do that? We usually do that by simply pointing, okay? You have your question, you underline what's relevant in the question, which includes the location, and then you simply match up with two hands. One finger on your right hand would point to the text area here in the question, and the other hand, in this case if the question was here on the right, my right hand would point to the things I underlined in my question, and my left hand would actually match that up on the other page, or where they tell you that data is, or give you that data. All right, simply point. How do you know and how can you predict when you're going to have to point a lot? For me, this is what I do. When there's lots of data, which is basically a graph or a chart, there's lots of pointing. Why? Because it's a great way to get lost. Tons and tons of information. They hide the right answer inside different graphs and different charts that are related somehow, so it gets confusing. So remember, underline what's important from your question and simply point from what you just underlined to into the data where it tells you. I can't tell you how many times I've seen kids do this. It tells you go to figure 1 and find this, and then figure 2 is talking about this, and you kids just go to figure 2, and it says right in the question, it says go to figure. I go, where are you? They go, oh, I'm looking over here because it says this star. Yeah, and figure 2 is about star. Yeah, but it tells you in the question right there, go to figure 1. Oh, you pointed to the wrong area. Kids, the most important thing, underline what's important, and then get there by pointing. All right, so let's say that you did that, but we still can't answer the question. What we're going to do is we hit the yikes area, and we need to supplement our understanding by simply finger scanning for something that's relevant in the question, all right? A noun or a verb. For me, since it's science, science is dealing with stuff moving around. I love the action words, the verbs. That's what I usually will look for in the question for finger scanning to supplement a yikes problem. All right, remember, to summarize what I just said here, the steps in science: underline what's important, point to the right area, and then when you can't answer the question, you have to go back into the question and underline something relevant, usually the verb, and then go back up into the text area and finger scan for that one term. All right, let's go ahead and take a look at a nonsense example I just quickly made up here. All right, so here's what we have. We have our data here, which is a figure, and we have chart over here. Figure 1, table 1. And here we've got a text region for figure 1, which is going to explain a little bit about this. And we've got text region for table 1 up here. And then up here at the top, let's just draw a box here. This would be the mini introductory paragraph, which talks about both of them. All right. So here's our question. It says, figure 1, we underline the location. We underline what's relevant. Digit mammals, dumb, are classified into 2 subcategories, which grabber clutch. Which one is the firmest? All right, so let's go. I underlined all that. Now let's go back in here and point. I underlined what's relevant. Now I have to get to the right area. Figure 1, where's that? That's table 1. Here it is. digit mammals, no, digit. Here it is, digit, okay. And thumb. Oh, there it is right there. Looks like, okay, I'm starting to see how this works. Looks like all of these are subclassifications, right? Okay, so I pointed to the right area, and then it says grab or clutch. Oh, okay, so here's grabbing. Maybe clutching is a Scooby-Doo for a light version of grabbing. Grab, clutch, whatever. Okay, great. All right. Got it. And then you look down here at your answer choices, and you see that you can't really answer the question because nothing is relevant from where you just pointed. Say that my finger is right here. That's when you hit the yikes. Oh my goodness, I can't answer it. Most kids at this point are going to give up and just look for something that's just relative to where you're pointing to, and that's the wrong answer. So what we need to do is, when we pointed, we got to the right area from the underlined text. We can't answer the question. Now we just need to lift up your finger that's in the answer choices and finger scan for a word that's relevant. Like I said before, I like verbs in science. So we already did this. It's figure 1, digit mammals, thumb, grabbing or clutching, and digit that's the firmest. Okay, so since we already pointed to all this, do you see how firmest, that's like an action? I'm going to take that word, I'm going to go up into the text region up here. This is the first place I would start. Why? Because this is the text region dealing with figure 1. All right? I'm going to go in here, finger scan for where it says firmest or a Scooby-Doo talking about firm. It could say 50 pounds per square inch, which would be pretty firm. Tight. That's also a Scooby-Doo for firm. Oh, there it is right there. It says tight. I read this, and then it says something a little bit down here. It says ring finger. Okay? Then I would take that information and drop it back into the answer choices. Okay? That is a yikes. All right. One last thing before we actually take a look at some working examples together is this, that this is the text region for the first scientist or for the first figure. However, if you come back up here and it didn't say anything in regards to firmest, the next place to look would be up here in the mini introductory paragraph. Up at the top. Bottom line, we just need to find the correct area. Most of the time, when there's data, we're going to just be able to point. However, heavily weighted passages that contain text, they can hide definitions in the text area. That's what we call yikes. All right, let's go ahead, turn the page, take a look at a working example. Kids, let's take a first look at yikes problems for ACT Science. We're going to bounce around a little bit here, so make sure you have your booklet open to passage number 6, and the question that we're going to work on is problem number 31. Now, in this little mini tutorial, what I'd like you to do is don't answer this question, just follow along with the logic and try and just see what's going on here. All right, so first thing that we do, step number 1, is to read the question. Based on the passage, what's the correct order of rain droplets, water droplets, cloud droplets, according to the diameter from smallest to largest? All right, so right away, there's no location for me to underline, so I know I'm going to have to go rain droplets, underline that, water droplets, and cloud droplets. And we're looking for small to large, all right? Small going to large, all right. Then, first thing that I would do is I'd come over here and I'd look at my XY axis for the graphs and charts because it is data. And I feel like, let's see, ascending, percentage, kilometers. Yeah, Yikes, see it? I can't answer this question from just looking at the data. So what we know for sure is we still can answer this question. What we have to do is just get to the right area. When we point and can't answer the question, we know now it's time to finger scan. And that is a classic example of a yikes problem. So these terms here, we have to now go away from our graphs and charts and go up into the text area and start reading. All right. In a rain cloud, small particles, condensation nuclei attract nearby water droplets. That's one of our terms over here. Okay. To form a cloud droplet. Okay. Cloud droplet grows and attracts more and becomes a rain droplet. So here it is. It goes water droplet to cloud to rain. We got the information from finger scanning in the text area. Now let's go ahead and answer the question. It goes from the smallest, water droplet, cloud droplet, rain. So those two are out right away. And it's water droplet, rain, or water droplet, cloud. Boom. Answer choice B. Classic example, kids, for yikes problems. Let's go ahead and take a look at the next one. Kids, let's take a look at another example of a yikes problem. It's passage number 1, question number 1. Here it is right here. So first thing that we want to do is underline everything that's important after you read the question. Based on the figure 3, water depth of 0.8 meters, the chute length and dry mass of how many species B seedlings were plotted. All right, great. Second thing that we're going to do is go over and take a look at figure 3. Okay, so figure 3 looks like figure 3 is down over here. Here. And we're looking for 0.8. So that's this line here. Okay. Right here. And we are looking for chute length. So that's the y-axis and the dry mass. So we look at the x and the y-axis of this particular line. All right. And it says species B. So wait, what are we looking for? How many species B were plotted? Let's see. This is the mass. And this is the length. It doesn't say how many species. Uh-oh. See what we just did there, kids? We yikesed out. All right? So what we want to do now is we want to go up and take a look and see where it says species B. Here it is, species B. All right? Now we just read that. For each water depth, the chute length, dry mass for each surviving. Whoa, okay. For each surviving species B, and that gave us this information. So now I know that not only are we looking for species B, but we're looking for surviving species B. So what do? We go back up because we still don't have enough information. We come back up here, it's surviving seedlings of species A and species B. And here it says after study 1. So it doesn't say how many species B were surviving. It just says surviving. So I feel like this question is pretty tough. We come back over here, and since it told us to look at study 1 after, let's see at the bottom down over here, does it say how many species B survived? So we look over here, blah, 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 blah. 8 seedlings of each species were submerged in these lengths. Late September, the average chute length for surviving A seedlings, and there it is, seedlings B, at the 3 water depths was determined. Okay? Never says how many survived. It says that we plotted 8 each. See that back up here, kids? in 3 water depths, 8 seedlings per. Never tells us how many seedlings actually survived. The question cannot be answered, so the answer here for answer choice, or problem number 1, the correct answer choice is going to be answer choice D as in dog. The most important thing that I want you to take away from this question is we pointed to what was important, found all that stuff, and we stalled out. We couldn't answer the question. So what we did is we had to go back up, and then finally go back down into study 1 to just triple check our information. Yikes problems, kids. You see what you need to do. Now, here's what we're going to do. We're going to go ahead and we're going to take a look at 2 particular problems. You're going to work these on your own, and I'll come on back with answers and explanations. Kids, let's go ahead and walk through question number 36 and passage number 7. Now keep in mind this is a training video. You're here to get some secret tips, so I'm not just going to give you the answer. Here we are. Step number 1 in problem number 36 is to go ahead and underline what is relevant, important in the question. What is the resonant angular frequency of the RLC circuit in the conditions in figure 2. First thing that we want to do over here is go ahead and find figure 2. Figure 1, figure 2, here it is right here. All right, so we found that, and now what we want to do is we want to find the RAF. Okay, so I look at my X and Y axis. Here it's radians per second, and here is milliamps. I don't see anything that deals with RAF, resonant angular frequency. So right away we yiked out. What we need to do now is from the data, we need to go right back up into the text and try and find out what the heck an RAF is. All right, so right from here, when we yikes out, we can't answer these questions. There's nothing there. We go all the way back up here, and when we do that, we're going to try and find where it says RAF. Let's see, anything that says RAF, resonant, hey, there it is right there. The angular frequency of a current, there it is right there. It's a small little w. Now, we take this information from finger scanning and let's throw it back into, in this particular case, the graph. So we're looking for W. Let's see, W. See it right here, kids? Up here, W and W0, it tells us that the arrow points to the number 1. Then over here, you see that we're in 10 to the 7th. So the correct answer here is going to be 1 10 to the 7th, which is H. Did you see that? Classic example of a yikes problem. Let's go ahead and take a look at problem number 39. Let's go ahead and take a look at 39. Question number 39, first thing we do is underline what's relevant here. According to figure 2, we're looking for WO and varying it with R. Second thing that we're going to do is go into the passage. We're going to look for figure 2. Let's go ahead and find it. Figure 2, figure 2, figure 2. There it is down here at the bottom. Okay. Then what we're going to do is we're going to look for WO varying with R. So here we have W, here we have I, and where's R? Let's see. Okay, R is the line. See that? So it looks like we've got the lines R. And then we have I, that doesn't have anything to do with the question, and then W down over here. Wait, okay, yikes. You see that? I hate all of the answers because there's nothing there. Yikes. Kids, let's go back and take a look at that question again. What am I looking for? Look at what we underlined. Figure 2, right? And R, but wait a second. We're looking for W sub O, sub 0, all right? Go back over here, we didn't find that. What did we find? We found W. See that? W is right here. So what we need to do is we need to try and find out where W sub O is. We go back up, start looking around for W sub O. From here, we go back up here, look in here, W sub 0. W, there, we're looking for this though, W sub 0. Kids, you see what's going on here? We are looking for something, there's W again. We're looking for this, can't find it. Let's go back into the chart. Get your eyes open, all right? There it is, right there, you see that? W sub O is a value. That value is a peak of 1.0, all right? When you look at your answer choices, you see our answer choice does not change. The value WO does not change. W sub O equals 0. So there's no change on that. All right? Because it stays the same. It's 1. The correct answer is going to be answer choice D. All right? According to this, does it vary with R? No, it doesn't. It doesn't vary because it remains the same. WO remains the same. Classic, kids. You got to find the right area. When you find the right area, you're going to see it falls into your lap. Yikes! Make sure you understand what yikes means. Yikes means just simply get to the right area. As I taught you before, if you point from the text into the data, most of the time you're going to be able to answer the question. However, sometimes we need to add more information in, and that's when we would finger scan. Yikes means you need more information from the text. That's it for the Yikes Hack It video, kids. Thanks for watching. Bye for now.